Hello guys, good. Hello guys. So myself Dinesh Kumar, and these are my credentials. So in today's session, we'll be discussing GATE 2017, GATE Aerospace Engineering Aircraft Structures Module Part Detailed Solution. So this aircraft structures module has three subjects: SOM, strength of material, mechanical vibration, and the third one is thin walled structure. Okay. So in GATE 2017, if you see the marks distribution, there are 6 questions for 1 marks and there are another 6 questions for 2 marks. So the total marks are 18. So for 18 marks, aircraft structures module was asked. So read. So if we look first question, what it says, the question number 20, which of the following statements about the neutral axis of a beam with unsymmetrical cross section is true? So first option says the product of second moment of area about neutral axis is always 0. So guys, if we take any arbitrary cross section and suppose this is our centroid, okay, so we know the second moment of area, okay, if we take about this x and y about x-axis, so my ixx is what? Integral y square dA. Now this y is measured from what? Centroid, measured from centroid. Y is measured from centroid, and we know neutral axis passes through centroid, so this can't be 0, this cannot be 0. So the first statement is wrong. What second statement says? The normal stress along the neutral axis is always 0. So we know normal stress sigma z. In case of unsymmetrical bending, it is k1x plus k2y. And we know at neutral axis, your x na will be y na, and these are 0. Okay. So at neutral axis, these x and y distances will be 0. So your sigma z is 0. Your bend normal stress is 0. So it is correct. What is the option C says? The shear stress along the neutral axis is always 0. No, it is wrong. How? We know if you take a simple rectangular cross section, your shear stress distribution is parabolic. Okay. So for unsymmetrical section, this distribution may vary, but at neutral axis, this tau, which is shear stress, is what here? Max. Okay. So it cannot be 0. It is 0 at what? Top and bottom of the beam. So statement third is wrong. And statement fourth is what? The product of second moment of area about neutral axis and the normal stress about the neutral axis are always 0. So anyway, if statement A is wrong, then D is also wrong, because first part of D is from statement A. So the correct option in this case is what? B is the correct answer. So what is the correct answer? Correct answer B is the correct answer. So let's move to next question. What it says? This is the question number 21. It is for 1 mark. Assuming that the aircraft is flying straight, the top spar cap, comma, flange of a wing is most likely to fail. So if you see your aircraft in steady level flight, okay, in steady level flight, your wing will be deflected upward like this, okay. So there is a bending in the wing, and the bending in the wing is what? Sagging bending. So when there is a sagging bending, if you take a single wing part, when it is a sagging bending, you will see on the top of the wing, top part of wing will undergo what? The top part of wing will undergo compression. Now, if we see the cross section of the wing, this is what your cross section of the wing. In this cross section, you can see this is the top side. So this top side is under compression. So when the top side is under compression, where your spar, caps or flanges are located, it cannot yield, cannot fail by yielding, because for failing under yielding, you need to have tensile load. Now, buckling, yes, since wing is a long structure, okay, wing is a long structure, and the spar run through wing, okay, so it's like one side is fixed, other end is free, so that means the buckling strength will be lower for fixed free column. Always buckling strength is low, so it may fall under buckling. Crushing will not happen, because we know the compressive strength will be higher, okay, compared to your compressive strength is higher compared to yield strength, and also the structure is long, so it will not fail under crushing, and creep will not happen. Creep is a failure with the time. So the correct answer is what? Buckling is the phenomenon by which wing is most likely, this spar cap of wing is most likely to fail. So B is the answer. Let's move next question, what it says. A 2 degree of freedom undamped spring mass system with 2 masses and 2 spring has natural frequencies omega 1 equal to 0.79 radian per second, omega 2 equal to 1.538 radian per second. The mode shape for the systems are given phi 1 equal to this and phi 2 equal to this in matrix form. If the first mass is displaced by 1 centimeter, the minimum displacement in centimeter to be given such that the second mass that the system vibrate only in first mode. The system vibrates only in first mode. So what is given here? Omega 1, which is how much? 0.79 radian per second. What is the omega 2? It is given as 1.538 radian per second. Then what is the phi 1? Is the amplitude ratio for first mode. So it is what? X1 by X2 for first mode, and it is nothing but X1 1 by X2 1, and it is given as what? Transpose of the matrix. So it will be 0.7321. Okay. Now what is the phi 2? Phi 2 is amplitude ratio for mass 1 to mass 2 for second mode. So it is x12 by x22, and it is given as how much? It is given as minus 2.3 minus 2.731. Okay. Now guys, we know for 2 degree of freedom system, the final response equations for mass m1 is x1 1 cos of omega n1 t plus x1 2 cos of omega n2 t. This is the final response equation. For mass 2, it is x2 1 cos of omega n1 t plus x2 2 cos of omega n2 t. Now guys, at t equal to 0, what is this? This is what the initial displacement of mass m1. So it is usually x1 1 plus x1 2, and same way the initial displacement of mass m2, it is x2 1 plus x2 2. So guys, you guys must remember these four equations, okay, as well as these mode shapes. Now guys, here it is given the initial displacement of mass m1, which is how much? It is given as 1 centimeter, and they asked this initial displacement of mass m2, but it is in such a way the system vibrates only in first mode, means this part is 0. So this part is 0 means what? This part is 0 means this is 0, this is 0. So from here we can see from this equation your amplitude for mass m1 corresponding to first mode is 1. And we also know this x1 for first mode by x2 for first mode is given as how much? 0.732. It is given as 0.732, okay, by 1. So guys, what is unknown? x2 1. So from here my x2 1 will be what? 1 upon 0.732. So which will be nothing but, which will be how much guys? If you find this, just a minute, it will be 1.36. Now guys, if you see, they ask what? The initial displacement of mass m2. So that means from this equation, from here you can see the initial displacement of mass m2 is nothing but x2 for first amplitude, which is nothing but 1.36 centimeter. So our answer, the initial displacement of mass m2 is what? 1.36 centimeter. If this, then the system vibrates only in first mode. So here our answer is what? 1.36. Now in this question, there is no use of given data like omega 1 and omega 2. See, omega 1 and omega 2 is required to find this amplitude ratios or mode shapes if it is not given, okay. So you can see in 2 degree of the problem what all things you guys need to understand. First, these are my final responses when your initial velocities are 0. Initial velocities are 0 guys in case of initial velocity, and it is already told in the question. The system, okay, it is given. Yes, natural frequencies are given. Mode shapes and system displaced minimum given second mass system. Yes. So usually they will write the system vibrates from rest. So your initial velocities will be 0. So the answer here is 1.36 centimeter. Read next question what it says guys. An aircraft landing gear can be idealized as a single degree of freedom spring mass damper system. The desirable damping characteristic of such a system is, so any mechanical system, if you take any mechanical system, is desired to design for what kind of damping? Always critical damping. Why for critical damping? Because the critical damping is corresponding what? The motion will be non-oscillatory. The motion will be non-oscillatory, and the system will take minimum time to come to rest. Okay. In case of underdamped, the motion will be oscillatory motion, which need to be avoided. Okay. And sorry, it is undamped. Undamped means free vibration. So it cannot be the case. You don't allow your system to vibrate freely. Underdamped. So in case of underdamped, the motion is oscillatory, so which need to be avoided. And overdamped means the motion will be non-oscillatory, but the motion will be more sluggish, means the system will take more time to come to rest, which we cannot allow. Okay, so always any mechanical system is designed for critically damping. So let's see the next question, what it says. A single degree of freedom spring mass system of natural frequency 5 Hertz is modified in the following manners. Okay. First, the case 1, viscous damping with damping ratio zeta equal to 0.2 is introduced in parallel to the spring. Case 2, the original undamped spring mass system is moved to a surface coefficient friction mu equal to 0.01. So what is asked? The ratio of damped natural frequency for case 1 to case 2. So that means what? Damped natural frequency means asked omega d1 by omega d2. Now the K initially the system is vibrating freely. It's a undamped system. Okay, undamped system. So we know what is the natural frequency for undamped system. Omega n is under root K by M. In case 1, what they do? They put a parallel damping. Okay. So in this case, we know omega d1, your underdamped natural frequency is given by what? Under root 1 minus zeta square into omega n. Okay. Now guys, case 2 is Coulomb's damping. So in case 2 Coulomb's damping, what is done? This spring is connected with mass, but this mass is placed on a rough surface. So in this case, we know for Coulomb's damping, there is no change in natural frequency. So your omega d2 will remain omega n, and it will be under root K by M. But we know in case of Coulomb's damping, what is the amplitude loss? It will be like, in one cycle amplitude loss is what? 4f by k. Okay, so that is different thing. So in question they ask only what? Omega d1 by omega d2, which is nothing but under root 1 minus zeta square omega n by omega n. So it is under root 1 minus zeta square. It is 1 minus, what is the zeta value? It is 0.2. So it is under root 1 minus 0.2 square. So which will be coming as 0.97. So my answer for this question is what? 0.97. So guys, in your GATE exam, till now from Coulomb's damping, they asked only one question. Okay, this question. So this is just based on natural frequency, which doesn't change for Coulomb's damping. But there are further things which we study at IGC, like what is the total amplitude loss in a cycle, and then further the system, how many half cycle system can sustain before coming to rest. Okay, so those kind of questions we have put in our mock exams. What this question number 6 says, which of the following statement about the compatibility equations are true? So what it's first, strain compatibility equations must be satisfied in the solution of three-dimensional problem in elasticity. Second statement says 6 strains are defined in terms of 3 displacement functions and can have arbitrary values. And statement R says compatibility equations are an expression of continuity of displacement. So basically, what is the compatibility equation in solid mechanics? Compatibility equations ensures your displacements are continuous, the displacements are continuous and single valued. Okay, so that means the displacements are single valued. So that means this statement R is correct. Compatibility equations are an expression of continuity of displacement. Yes. If you look option Q, what it says, 6 strains are defined in terms of 3 displacement function and can have arbitrary values. No. Yes, we define 6 strain, which are what? Epsilon x, epsilon y, epsilon z, then gamma xy, gamma yz, gamma zx in terms of u, v, and w. But this u, v, w should be single valued. So statement Q is not correct. Then what about statement P? Strain compatibility equation must be satisfied in the solution of three-dimensional problem in elasticity. Yes. Okay. This must be satisfied. So what are the correct options? Option is P and Q. See, this compatibility equation ensures when it is satisfied, the displacement are continuous and single valued. So though A is not correct answer, what is the correct answer? C, P and R is the correct answer. P and R is the correct answer, guys. P and R the correct answer. So let's move to next question, guys. What it says. Yeah. So this one of the question is from vibration, and it is also solved in our by our mathematics. So what it says, let u x comma t denotes the displacement of point on a rod. The displacement satisfies the following equations of motion. Okay, so this is the governing differential equation for continuous vibration of rod or bar. Okay, and this is valid for x greater than 0, less than 1. So with given condition, so you can see ux comma 0. So what is this? It is an initial displacement. Okay, no, yes, initial displacement, or you can say displacement at t equal to 0. Du by dt, it is what? Velocity, which is not like u naught, you can say u naught at t equal to 0. So you can say in this case the initial velocity is 0 and initial displacement is given by this, and these are boundary condition, u at x equal to 0 as well as u at x equal to 1. So these are 0. So what it means, you have a bar or rod which is fixed at both the ends. Okay, now from this we can write in this form also, dou square u by dou x square equal to 1 upon 25 dou square u by dou x square. So here if you compare your this equation with governing differential equation, you will find c square equal to 25. So c is 5. Now guys, we know for continuous vibration of rod or bar, the final solution is given by what? U by variable separable method, we find u of x and then u of t. Now, what is the u of x, guys? It is u of x, it is a sine omega by cx plus b cos of omega by cx. Okay, and then what is u of t? It is c sine omega t plus d cos of omega t. So now, guys, if I take separately u of x alone, what it is? It is a sine omega by cx plus b cos of omega by cx. Now, what is the given boundary conditions, guys? U at x equal to 0, it is 0. So from here, what we find, guys? 0 equal to 0 plus b. So from here we got b equal to 0. Now, guys, the next, what is your u of t? It is c sine omega t plus d cos of omega t. Now, guys, what is your dou u by dou t? It will be c omega cos of omega t when we differentiate, then minus d omega sine omega t. Now, guys, when we substitute at equal to 0, what we find? This is 0. The given initial velocity is 0. So from here, what we see? 0 equal to c omega minus 0. So from here we can see c is 0. This c is different from what this c. Okay, so this c is different, or instead of c, guys, this omega by small c, and this is constant. So this constant capital C, I'll write capital C, it is 0. So that means your this response equation will be what? It will become like this: u x comma t, it will become a into c is 0, so it will become a into d. Okay, a into d sine omega by small c into x, then cos of omega t, because d is non-zero. In this equation, when c is 0, this will be 0, and when b is 0, this part will be 0. Or you can say your this part is 0. What we find? AD, what we find?
You are currently the only person in this conference.
Yes, guys, am I audible? Yes. So you can see, guys, we compare given, okay, which is like ux comma 0, we got AD sine omega by Cx, and with given condition at t equal to 0 initial displacement is given, so AD we are getting 0.001, 0.01, and omega c equal to 10 pi, and we know this is small c is 5, so from here omega is coming as how much? 50 pi. So finally, if you write your ux comma t, it is coming as how much? 0.01 sine omega by c is 10 pi x, then cos of omega t. So cos omega is how much? 50 pi t. Now guys, what is asked in the exam? It is u at x equal to 0.25 comma t equal to 1. So what it will be? 0.01 sine 2.5 pi, when you substitute 0.25 here, and cos of 50 pi. So we know sine 2.5 is 1 and cos 50 pi is also 1. So your answer is 0.01. 0.01, guys. Now again I will repeat this question. What are the steps we did? First, we know the generalized solution for continuous vibration of bar and rod, and with the given boundary condition at x equal to 0, we found this constant b equal to 0, and with the given initial condition. Initial condition means at t equal to 0, your velocity is 0. So from here, this constant capital C is 0. So finally, your final response equation is given by AD sine omega by Cx cos of omega t. And we also know another condition at t equal to 0. What is the displacement? This. So when we compare these two equations, we find the value of AD and the value of omega by small c, and from here omega is 50 pi and AD is 0.01. We substitute in this final response. This is our final response for the given problem, and then at x equal to 0.25 and t equal to 0, they ask what is the displacement. So it is 0.01. So hopefully it is clear to everyone. Now, next question, what it says, it's a question number 51. An aircraft wing is idealized as a cantilever beam of constant width and length L with a tip mass of weight W and has a uniformly distributed loading of Q0 newtons per meter, as shown in the figure. Flexural rigidity is given as EI. This Q0 into L is given as 10W. So if you multiply here, uniformly distributed load into length is given as 10W. So this is the cantilever's wing idealization. You can see the UDL is acting upward, and the point mass, we know the tip mass will be acting always downward. The upward deflection of the tip of the aircraft wing under given loading can be expressed as delta equal to K times WL cube upon EI. They have asked the value of K. So guys, for this cantilever beam, this UDL, which is the lift, is acting upward, and this point mass is downward. So we know guys, we know when aircraft is flying, your wing will be deflected upward. The wing will be deflected upward. Okay, the wing will be deflected upward. So that means your net deflection delta will be upward. So that means it is what we can use method of superimposition. So this will be what delta due to UDL. So what is the UDL? Q naught. Then the wing deflection due to this point mass will be downward. So it will be minus delta due to this weight. Now due to UDL, we know that deflection at free end is given by Q naught L power 4 upon 8 EI, and we know due to point load it is WL cube upon 3 EI. Now in given question they given Q naught into L equal to 10 W. We can substitute here. So it is 10 W L cube upon 8 EI minus WL cube upon 3 EI. Now when we take LCM, we will get 22 by 24. This is delta, and it will be WL cube upon 3 EI. So 22 by 24, it is nothing but 0.916 WL cube upon 3 EI. So in given question, they ask what is this value. So your K is 0.916. Okay, so this kind of question, guys, don't use any methods like moment curvature method or area moment method or anything. The best way is to use method of superimposition. Method of superimposition. So what is this method of superimposition? We divided this wing in two different case. One is the UDL, okay, and another is this point load. So due to UDL, you can say deflection is upward, so it is positive, and due to weight, it is downward, so negative. So we got the answer. So guys, let's move to next question, guys. What it says: for the state of plane stress shown in the figure, the minimum principal stress is 0.7 megapascal. The normal stress sigma x in megapascal is equal to. So this sigma x is unknown. So how we can find this, guys? So guys, in this case, what is given? Sigma x is unknown. Sigma x is unknown. Sigma y is given as 21 megapascal, and tau xy is given as minus 56 megapascal. Why minus 56? Because as per our sign convention, our stress element will be like this, and this should be the tau xy's. Okay, but this minus sign will not change anything here in this problem. Okay, and they also given one of the principal stress. I am denoting it by lambda, and it is given as minus 7 megapascal. So now, guys, I can write this sigma. In matrix form. Means I can write my stresses in matrix form, which will be what? Sigma xx, then sigma xy or tau xy, and then sigma yy. So if you write matrix here, what is sigma ij? You can say sigma x is unknown, then tau xy is minus 56. This is minus 56, and sigma y is given as 21. Now, guys, if you want to find the principal stresses from this matrix, what you can find? You can find eigenvalues of this matrix. So what will be the eigenvalue? How we find? We find by solving the determinant of sigma ij minus lambda I equal to 0. What is here I? Here I is identity matrix. Okay, so that means here it is what? Sigma x minus lambda, then minus 56 minus 56, then it is 21 minus of minus 7 is equal to 0. So from here you can see it is sigma x minus lambda into 28 minus 56 whole square equal to 0. So you can say sigma x minus lambda equal to 56 into 56 by 28. So it is nothing but 112. So sigma x, now lambda was already given right here, so it was minus of minus 7 equal to 112. So from here you can say sigma x is 105. Okay, so here I have substituted lambda. Here also we can substitute this lambda value, which is what? Minus of 7. So you can say here also this is like minus minus will become plus. So you can say sigma x plus 7. Okay, so we can solve this kind of problem using this matrix method approach rather than solving conventional approach. Next question, what it says: the maximum normal stress in megapascal for thin walled beam of square cross section, square cross section square cross section okay, square cross section of outer dimension 120 mm by 120 mm and wall thickness 1 mm under the action of moment m naught equal to 96 Newton meter as shown in the figure. So guys, in this question they ask maximum normal stress. So what will be the maximum normal stress, guys? It's actually, in this case, it's a bending stress, maximum normal stress. So which is like nothing but our max bending stress. Now guys, given cross section, if you see the given cross section is symmetric cross section, so your ixy is 0. So what it means, your bending stress, okay, because this is bending moment, so your bending stress, okay, your bending stress for this case, and in this case you can see your moment is neither about x nor about y, it is in about a inclined axis. So in this case your mx is what? M naught cos 45, and your my will be here minus m naught sin 45. Now why it is minus sign here, guys? It is from sign convention. So we know our bending stress formula for unsymmetrical bending, the sign convention for is given like this. This is the positive mx and downward will be positive my. This mx and my will create tension in first quadrant. That's what the sign convention we use. And what is our bending stress formula? My sigma z will be what? It will be my ixx minus mx ixy upon ixx iyy minus ixy square into x plus mx.
You are currently the only person in this conference.
Okay, guys. So in this case, you can see this is what your sigma z, and we know ixy is 0. So your sigma z, which is your bending stress, sigma z will be given by what? When ixy is 0, so you can say it is my upon iy into x plus mx upon ix into y. Now, since it's a square cross section, the cross section is thin walled square cross section. So here ixx is equal to iyy, and we can find it is like outer dimensions they have given. So which is how much? 120 by 120. So it is 124 by 12 minus 118, because the thickness is 1, so it is 118 power 4 by 12. So ixx and iyy we can calculate. Now guys, this sigma z, so sigma z, if you substitute my, it is what? Minus m, the value is given as what? How the value is given, guys? It is m naught, so it is m naught, okay, it is m naught sine 45 by iyy into x plus it is m naught cos 45 by ixx into y. Now in this question there are 4 points you guys can see. One point is 60 comma 60, then here it is minus 60 comma 60, and then minus 60 comma 6 minus 60, and then it is 60 comma minus 60. If you see this given problem, so we already know ixx and iyy is same. So in this case, if x equal to y, what will happen? Your sigma z will become 0. Okay, because this and this ixx and iyy is same, and if x equal to y, this will become 0, because we know m naught sine 45 and m naught cos 45 is same. So that means on this point and on this point, your sigma z is 0. So that means this will be your neutral axis. Now the maximum value, either it will be here or here. In this case, here it will be tensile. So my maximum sigma z max value will be what? It will be 2 times m naught by under root 2 into ixx or iyy into 60. Okay, so if I substitute all the values, my answer will be 7.07 mega Pascal. And from here, if you find your ixx iyy value, it will be coming as how much? 1123518 power 4. So that's how we need to solve this question, guys. Okay, let's see the question number 54. What it says: the idealized cross section of a thin walled wing box structure shown in the figure is subjected to an anti-clockwise torque of 10 kilonewton meter. The corresponding shear flow distribution under this loading condition is shown in the figure. The area of each cell A1 equal to 300 into 10 to the power 3 mm square, and A2 is given 250 into 10 to the power, it given as 250 into 10 to the power 3 mm square. The ratio of the unknown x and y is given by. Now guys, if you see this question, it's a multi-cell question, and for this applied torque for multi-cell, suppose this is my shear flow Q1 in this area A1 and this is my shear flow Q2. So if you see here, there is no jump over these booms. So that means only torque is applied. So that means you can see here shear flow here and here it is same. So that means only torque is applied. So from Brad-Weather theory, we know T equal to 2A1 Q1 plus 2A2 Q2. Now here guys, what is the Q1? Q1 is given as 5 Newton per mm. 5 Newton per mm. It is okay. And this, what is the Q2? Q2 is here Y. So if I substitute in this Brad-Weather theory, what is the torque? Torque is given as 10 kilonewton meter. So it is what? 10 into 10 to the power 6 Newton mm. So this equal to 2. What is the area? Area A1 is 300. So it is 300 into 10 to the power 3. What is the Q1? It is 5 plus 2 into 250 into 10 to the power 3 into this Q2, which is Y. Okay, unknown. So from here Y will be coming as 14 Newton per mm. Now guys, in the given question, what is asked? X is unknown. Your X is unknown, and they ask the ratio of X by Y. The ratio of X by Y. Now what is the X guys? X means you are moving 3 to 4. The shear flow in this web 3 to 4. So which is what? X. So my X is nothing but it is Q2 minus Q1. So what is the Q2 guys? So from here you can write X is what? Y minus Q1. Okay. Now guys, they are the ratio of X by Y. So from here X by Y will be what? 1 minus Q1 by Y, and Q1 by Y is what? 5 by 14. So 1 minus 5 by 14. 1 minus 5 by 14. So the answer is 0.642. So what is X by Y is coming as 0.642 is my answer. Okay, so this is how we have to solve this question. The last question, what it says: the natural frequency of the system, the natural frequency of the system suspended by two identical springs of stiffness K, as shown in the figure, is given by omega n equal to A under root K by M for small displacement. Both the spring make an angle of 45 degree with the horizontal. The value of A. So guys, in this case, you can see both the springs are not in vertical. They are in some inclination. So guys, in this case, when this mass is moved by some displacement x, the springs will not have directly the displacement of x. The displacement and spring, how we can find? You can see like this is like these two springs are some angle 45 degree. You can see these are 45 degree angle. Okay. Now guys, if you extend bait, here there is a you can say, if you extend further, so what will be guys, if this angle is 45 degree, okay, so you can say here my opposite angle, this angle is 45 degree, and this angle is also 45 degree. Now guys, this is what my x displacement. Okay, so guys, this angle is 45 degree, this is also 45 degree. So along my spring, my displacement will be what? Along my spring, my displacements will be what? X, 45 degree, 45 degree, 45 degree. So what will be my x displacement? My displacements will be what? X, 45 degree. My displacements will be what? X, 45 degree. 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 45 de cos 45. This is also x cos 45. Okay. So my spring force will be what? Kx cos 45, and this is also Kx cos 45. Now guys, if you resolve these spring forces in vertical direction, they will be added, but if you resolve in this horizontal direction, they will cancel each other. So if you take the equilibrium of this mass, there are two spring forces which will be what? Added, and you can say this will be what? 2k addition, or you can say separately it is k x cos 45 degree sine 45 degree. This is also kx cos 45 degree sine 45 degree, and inertia will be what? Also in the same direction, which will be mx double dot. So what is your equation of motion? Mx double dot plus 2kx 1 by under root 2 into 1 by under root 2. So you'll get mx double dot plus kx. Okay, you'll get mx double dot plus kx equal to 0. So natural frequency will be under root k by m. So the value of a will be 1. For this question, the value of a will be 1. So that's all guys from this lecture. If you guys have any doubt, be free to comment or ask us. Thank you guys.